So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, welcoming you all to a new amazing video in which we are gonna talk about this crazy integrals evaluation or maybe generalization, I would say. Well, why I'm considering this integral only? Because we actually I'm using this integral in one of or maybe two of my videos continuously, right? Basically, in the tetration videos, the integral from 0 to 1, right? So yeah, for that case I'm just using it, but I haven't proved 88. So that is why I'm thinking let's prove this down, because I would not say my audience to just memorize anything like this. Let's talk about the proof of this as well, so that you don't get any kind of thing like Aman used this thing without out of nowhere, or he did use of this but he didn't prove that 88, right? My philosophy says if I'm using anything, let's prove it down, right? And then I would use this, and if I don't know the proof of that, I would not use that. It's illegal. Okay, now let's talk about the proof. So basically, we have talked about the let's first talk about the gamma function, right? So the gamma function, and actually I have uploaded an introductory part of this gamma function, so you can just consider check that out, consider watch that. I would request you to watch that if you haven't watched that yet. So I would just plug the link of that video in the description box of this video. Don't worry about that. So basically, the gamma function is the integral of from 0 to infinity of t to the z minus 1 times e to the negative t dt equals gamma of z, right? So this is the gamma function, and I have proved this down. Basically, gamma of z is z minus 1 factorial, right? So yeah, basically when you solve this integral, so you're gonna have z minus 1 factorial, and which is being represented with the gamma function. That's it. So with the use of this one and with the use of an u sub, we are going to prove this down. So basically, we have the integral from 0 to infinity of t to the z minus 1 e to the negative a t dt. So for our u sub, let's say that let a t equals x, right? So t is going to be x over a. If we talk about the limits, so limits ain't gonna change, because when you plug t equals infinity, so that's gonna give us x equals infinity, and when t equals 0, x equals 0 as well, right? And if we talk about the derivative, so dt is gonna be dx over a, since a is a constant, right? So let's plug all the stuffs inside back our integral. So it's integral from 0 to infinity of t is x over a, so it's x over a to the z minus 1, right? And it's e to the negative x, right? At was x. Okay, and now we are having dx over a as the derivative factor. Now we are just going to split this exponents in between them. Like, let me just tell you something deeper. So it's x to the z minus 1 over a to the z minus 1, right? And it's e to the negative x dx over x, right? So yeah, and now our next step is we have to combine these two things. We do that because they are being multiplied to each other. It means their exponents are going to be added to each other. So it's x to the z minus 1, oh wait a second, x to the z minus 1 times e to the negative x over a to the z minus 1 plus 1. So that's gonna be cancelled out, and we would be left with a to the z only, right? So it's dx. So since a and z are independent of x, so we can just plug that out as a constant. So it's 1 over a to the z times integral from 0 to infinity of x to the z minus 1 e to the negative x dx. Or we can just consider changing the index variable, that is x with t here, and we can do that because it's not an indefinite integral, it is a definite integral, right? So we are having that it's 1 over a to the z times integral from 0 to infinity of t to the z minus 1 e to the negative t dt. Now I would like to just cover it in a red box here, and I would like to go a little bit upper, something over here. Look at them carefully. Let me just zoom out a little bit. Yeah, so it's integral from 0 to infinity of t to the z minus 1 times e to the negative t dt. So we are having it as gamma function, and hence we can say that our integral of t to the z minus 1 e to the negative t equals 1 over a to the z times the gamma function, or maybe we can say that gamma of z over a to the z. So this was the overall proof of that integral, and that was really easy to prove that down. It's literally easy. We just have to use this gamma function identity, or maybe introduction, gamma function introduction, right? And well, we don't need to care about this one, right? And then although I just told you that what is gamma function basically, and we just use this u sub. This is the key u sub here, and actually x sub. So that just helped us out to just reach our goal for now. So yeah guys, we have proved this. And again guys, if you got to learn something from this video, make sure to like, subscribe and share. And if you have any kind of doubt, make sure that it's your responsibility to ask me in the comment section. I'll be there to reply your doubts as fast as possible. And don't worry, I'll plug the link of the introductory part of the gamma function, as well as the oh yeah, okay, so I will just I would just paste the link of that video in the description box of this video, right? Okay, bye. Okay, I'm sorry. Okay guys, goodbye, take care, love you, and stay tuned for the next video guys, because I'm just coming with a lot of things crazy here. Goodbye guys.